Hello again, everyone. Mr. Cruze here, working through the 7.1 to 7.5 review again. This is another opportunity for you to prepare for your re-quiz tomorrow, okay? Please remember you still have access to me on Twitter, email, all these different places. You also now have 2 sets of videos over the same type of review, okay? So hopefully that'll help you along the way. Anyway. Looking at the instructions here, it says write the expression as a single logarithm. So as you can see, there's kind of a string of logs in both of these, and we want to put them together into a single log. Well, the first thing you have to take care of is any numbers out front of the logs, because those are actually exponents. So you have log base 3 of actually x to the 5th, okay, plus log base 3 of y to the 4th, okay. The 5 and the 4 just come up as powers, all right. Now, because again, like before, since this is addition, that means we're actually, because they're the same base, we can multiply what's inside the logarithm. So that'll be log base 3 of x to the 5th, y to the 4th. You're just multiplying. And obviously you can't combine that anymore. It is a single logarithm. We have done our job. Number 10, same thing, only this time I notice there's no numbers out in front of the logs, so we don't have to worry about that at least. Since this is subtraction, okay, let's think about this. If addition made it multiplication, then subtraction would mean division. So that'll be 10 over 2. This will be log base 6 of course, 5. Now, you might be wondering, how come we can't do what we did before and do log of 5 over log of 6? Well, they want it as a single logarithm, and if I were to actually take log of 5 divided by log of 6, it would be a number, not a single logarithm like we want it to be. Okay? 11 and 12 have us going backwards. This time we combine them and we want to split them apart. So let's deal with the division first. That'll be log base 3 of y. Since it's division, it kind of looks like a minus sign, so that'll be log base 3 of 5. And you notice there's no powers to deal with in either the y or the 5, so that's it. That's all you have to do. This one's multiplication, so that'll be addition. Log base 3 of y to the 6. And this time I notice the x has no power, but the y does, so the 6 has to come out front. So it'll be log base 3 of x plus 6 log base 3 of y. And there's that. Easy enough. 13, an initial population of 200 buffalo increases at an annual rate of 13.2%. So there's a couple things here. Initial population of 200 buffalo increases at an annual rate of 13.2. That means our R value is actually 0.132. Remember, you had to move the decimal point 2 places to the left in order to get that as a decimal. Okay. We want an exponential function. Well, this is just normal growth, so it's y equals ab to the x. And you may remember, for increasing, b is actually 1 plus your rate. By the way, if it was decreasing, it would be 1 minus r, right? Anyway, in this case, r is 0.132. So in this case, a is our initial amount, which is 200. B is 1.132. We just took 1 and added 0.132 to it, to the x. So there's our first part. Write an exponential function. Check. Now, what's the population going to be after 3 years? So I plug in 3 for x. And you can very easily just type this in your calculator. 1.132 to the third, hit equals, and then multiply it by 200. I do it safely in 2 steps. You could, if you are careful, 200 times 1.132 to the third. You could do it this way as well. You get the same answer. Anyway, what's the population going to be? Well, think about it. These are buffalo, right? So how do I round that? Well, I've got 290 buffaloes for sure, and like 0.114 of a buffalo. Is that enough to make another buffalo? No, it's just some buffalo parts. So we only have 290 buffalo. Okay, buffalo, 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 buffalo. All right. Suppose you invest $1,200 at an annual interest rate of 3.8% compounded continuously. This is important. Compounded continuously uses this formula, P e to the RT, where P is your initial amount. So here we go. P is our initial amount. E is a number. It's on our calculator. We'll find it here in a second. R is your rate. Well, again, You move it 2 places to the left, so it'll be 0.038. You'll notice this time we're not adding 1 to it. 0.038, and then t, which is 7. They didn't want the equation this time. We're just plugging it in. So here we go. I go to my calculator, and I can actually type this all in one. 1200 second e to the 0.038 times 7. And you get this. So in 7 years, I'll have $1,565.68. This time it's okay to round a little bit. Okay? So in 7 years, I will have that much. Okay? Simple enough. The half-life of a certain radioactive material is 530 years. Oh, half-life. That's this formula. A times 1/2 to the t over HL power, where t is time, HL is half-life, and A is your initial amount. So the half-life is 530 years. So we can go ahead and start filling some of this in. The t is going to be there, and the half-life is 530 years. Initial amount of material has a mass of 20 kilograms. There's your exponential function. Hey, wow, that was easy. Find how much material remains after 650 years. Now notice, since these are both in years, I don't have to do any converting. That's easy. I just plug it in. 20 times 1/2 to the 650 over 530. Now, a careful observer would notice, since 650 is bigger than 530, I should end up with more than half of this being gone. If I get some answer like 30 point something, that's really weird because I gained mass somehow. So let's figure out what this comes out to be. This one you have to be kind of careful on. 20 times 0.5, that's 1/2, to the, and then I'm going to use more parentheses, 650 divided by 530 power. Make sure you close parentheses, and we end up with this. Notice it says nearest thousandth. That's 3 decimal places, so 8.5475. So that 5 will round that up to 8. So 8.548. And just for good measure, use the correct units. So that would be kilograms, which makes sense. We started with 20. We already agreed that we were going to be more than halfway gone. So there we are. All right. Without graphing, determine whether y equals 2 times 5/4 to the x represents exponential growth or decay. Well, remember, growth is if your b value, technically the absolute value of b, is greater than 1. Okay? Greater is growth. If the absolute value of b is between 0 and 1, it'll be decay. Well, here's the thing. 5/4 is 1.25. It's bigger than 1, so that would be exponential growth. Okay, very little calculating. Some of us talked about this in class, okay? Oh, and then last but not least, we solve each equation. Remember, if they're exponential, you're going to log it. If they're logs, you're going to bump the base, okay? So, 2 to the 5x equals 15. Let's log it. Log of 2 to the 5x equals log of 15. We remember that the 5x comes out front. Then I can go ahead and divide both sides by log of 2. So I get log of 15 divided by log of 2. I can use my handy-dandy calculator to figure out what that is. 5x equals log of 15 divided by log of 2. That's 3 point... Oh, I might as well go ahead and leave that in my calculator. 3.9069. You know, I might as well use 4 decimal places. 9069. And then you can actually go ahead and leave that in the calculator if you want. Just divide that by 5 now. Anyway, it says round answers to the nearest thousandth. So 3 places, that'd be 0.781. Okay. So there you go. Same with this one. Since the exponential part is by itself, you can log both sides. Log of 3 to the 2x minus 1 equals log of 11. The 2x minus 1 comes out front. And you have log of 3 equals log of 11. So 2x minus 1 equals log 11 over log 3, which is not going to be necessarily a pretty thing. Let's see, log 11 divided by log 3. And I'll be pretty lenient here. I would go with 4 decimal places in the middle of the problem. That should be good. 2.1827. Is that right? 2.1827, yep. So 2x minus 1 equals that. You would add 1, and you would divide both sides by 2. So 3.1827 divided by 2. 1.591. Easy enough. Alright, and last but not least, these logs. As long as the log is by itself, it's just log of something equals a number, you can go ahead and bump that base. This base, when they don't write it, is 10, of course, so you're going to bump both sides by 10. The 10 and the log 10 will cancel each other out, so you're left with 2x plus 3 equals 10 to the first, which conveniently enough is just 10. And look at this equation. You could have done this back in 6th grade. 2x equals 7, which means x equals 3.5. And don't forget to round to the nearest thousandth. Don't work too hard on that. Okay. So this one, again, the log has to be by itself. So you divide both sides by 4 first. It'll make life easier. Log of 5x equals 4. Bump that base. Again, the 10 and the log will cancel, so that's 5x equals 10 to the 4th, which is actually 10,000, which is kind of nice. Uh-oh. They're trying to shut down my computer. That's awesome. Abort. Thank you. You know, 10, your powers of 10 are just how many zeros it has, so 10 to the 4th. And then you would divide that by 5, and 10,000 divided by 5 is going to be 2,000, so x ends up being 2,000. Easy enough. Remember, you can always Twitter me, email me. You can come in the morning. I do not have a meeting tomorrow morning. You may come in and ask any and all questions that you might have. Don't forget to use these videos in conjunction with the other videos. I'll link them below. Just remember the other ones didn't have like 7, 8, and 9 or whatever. That was my fault. But hopefully these help you, and good luck on your retests.